Same with river sediment flow and different things that'll pick up gravel, create conglomerated rock of different things. But you can, I mean, if you're going to test it, you know, the tester pretty much knows what they're testing. I mean, it's not, and if it melted together, well, then it would reset the clock of that rock as well.
Have they done any like deep core way down, gotten a sample that's really fresh way down, and then tested that? And how does that compare to like what's on top of the surface?
So the zircon crystals, those were actually found way deep down, and it was actually, I think it was a find in New Mexico that they found those, and they went pretty deep to find them, and they'd already been dated to be 1.5 million years old. But that's not billions of years old. That's relatively young, based on their belief on the ages of some of those rocks. So yeah, I think it's just really a challenge. And I suppose if you were to take core magma out of the earth, well, it'd be brand new. So nobody would even want to date it, because it's just like, well, it's just brand new, and we know that it's fresh, you know, freshly made rock.
That would be like the same philosophy of dating the seal.
Right.
Which is freshly killed and dated at 30,000 years or whatever.
Or the live snail. Yeah, I
Right.
mean, I don't know if the snail lived through that test, but it was alive when they got the test. And then here's another, some more basalt from, I'm going to mispronounce this, Mount Kiliao.
Kilauea.
See? I knew I would do it. It erupted in 1959, again, a known eruption, and it dated 8.5 million years old. So it seems like that the younger the things are, the older they're getting. And now here's one that we all kind of, at least in my lifetime, that erupted, was Mount St. Helens. And everybody in Colorado got a bunch of ash on their car. So in 1980, they took samples of a lot of the freshly hardened lava and got dates anywhere from 350,000 years, so that was the youngest, up to 2.8 million years old. And so, again, you know, these dates are out there. Scientists are pretty much aware of them. And that kind of brings up, we'll kind of talk about some other dating methods that are used for rocks. And so here's the other dating methods. When we talk about radiometric dating, that actually covers a lot of these. So samarium, neodymium, potassium argon is a very popular one, rubidium, strontium, and uranium, thorium. So you can, if you remember that uranium, it does decay to thorium, but thorium is still an element that's going to decay further yet. So that's what they use to date rocks. Now they can do all these tests on the same rock, and this is where I think their argument would be, well, you know, we do all these tests, and then when we intersect the dates, then we feel like we've got a good date. In other words, yeah, we can believe that there was probably daughter lead in the sample, which reminds me, this is your last eating. But we can't, you know, believe that there were all these daughter elements that were messing up. And so if we got consistency with potassium argon, uranium lead, and all of these other heavy elements, you know, then we feel like we've got a good date. And so that's where they'll kind of hang their hat as far as dating with some of these other elements. And so they'll do multiple tests at the same time. Okay, so we're done with our experiment, and we're also done talking about uranium dating. But so if you did it right, I think I've got a mistake on here myself. But the carbon-14 old Earth, you should have 10 green and 4 red. Is that true? All right. Got some counters here. Okay. And if you had the young Earth sample, the carbon-14, you should have the big green lifesaver still. Hopefully you didn't eat that. And 2 mini red M&Ms. The uranium lead, these are the blue and the yellows. If you had the no lead sample, basically this was just pure yellow, and you had to kind of add the blue to it. So you guys were really sugaraholics. There should be 4 yellow and 28 blue. Is that right? All right. Okay, and if you had the lead concentrated sample, that was with all the blue and just a little bit of yellow in it, you should have 0.5 yellow left. So you have a half a yellow jelly bean, if you really follow directions, and 51.5 blues. So you had to eat a blue in half just to make it all work out. So what does all of this stuff mean? So basically, you're going to get a percentage. So on the old Earth carbon dating sample, which was just kind of what you would assume as a scientist was old, you get a ratio of red to total jelly beans of 28.6%. And if you have the young Earth sample, you're going to get a very low number. And so basically, if you're a scientist, you're going to say that the young Earth is much older than that old Earth sample. Even though we were here, we followed the science exactly how the science works. But now all of a sudden, these two samples are going to date differently, just because they started out differently. And I think that was kind of obvious from the start, but that's actually, we don't know where a lot of these things start. And so you pick them up today and you just assume that you knew where they started, and that can be a bad assumption. We'll kind of talk about what that leads to in years. But so the no lead sample, again, this is a little bit different percentage. So basically, I'm now measuring the daughter element, the ratio of that to all the atoms. And so that's 87.5% on the no lead. When I do the percentage on the lead concentration sample, it's going to test 99.04%. And the higher the percentage, the more lead you have, the older that specimen should be. And again, we've both been here, we've both kind of been dating these, and so they shouldn't be different. So it still says eminence. Jelly beans. So basically, here's what would happen. We were here 30 minutes, or at least we did the experiment for 30 minutes. We know that they're both 30 minutes old, but here's how they would test. So if I were to pick up these samples based on how we did our ratios, the one that was old would have dated like it's supposed to. It would have been dated 30 minutes old. The young sample would have dated to be 150 minutes old. So even though, we're here the same amount of time, it dates older just because it started out differently. And that's just trying to kind of illustrate that if there was no carbon-14 in the atmosphere, so from the very start, actually, that young Earth sample would have dated. So if I would have picked it up and Adam and Eve were still kind of roaming around, I would have dated it to be 150 minutes old. And let's just pretend that these are thousands of years. So that's 150,000 years, or older. So that's how deceiving a lot of the carbon dating can be. When you kind of talk to somebody about carbon dates and different things, and again, this isn't information that's new to scientists. They're very aware that this is flawed. But when it hits the media, when it hits Discovery Channel, History Channel, and those kinds of things, it really just kind of gets stated as a matter of fact. And if you disagree with them, you're kind of crazy or something. But okay, so uranium, what happened there? So our older sample, again, would have dated 30 minutes old, just like it was. But when you look at the young Earth sample, it would have actually recorded to be 70 minutes old. So again, if you kind of look at these as billions of years, it's pretty old. Now, so some people can look at this experiment and say, well, yeah, but it's still billions of years. Well, if I would have taken that sample today and just said, okay, don't even do the experiment, let's test how old it's going to be like right now, it would have tested to be 40 minutes old. Or in the vernacular of the uranium, the billions of years, maybe 4 billion years old, even though it was brand new, just because it had heavy lead concentrations. So, again, when you hear the billions of years, I mean, I think that it's really important to kind of put that into perspective. What that really means is that a rock somewhere said that it had so much lead, so much uranium, so much potassium, so much argon, and not that it's really, that's how the dating methods are actually used. So before we go on to anything else, any questions on radiometric dating? You've got lots of them?
No, it's okay.
Okay. Just lots of questions.
Taking your word for it.
So,
I have a question.
yeah.
This may be dumb, but can you like date humans? Like, do they do that with like when a human dies?
Yes. So
Like,
that's,
what do they date? Like,
they would date carbon. So how much carbon-14 is left in the body, that's what they would use to try to date. Like, but it can only be up to 50,000 years old.
so when they date a human that they knew died at like 35 years old or something, what answers do they get? I guess. Like, do they get the?
Oh, they get some. So the last week's session, we kind of talked like the live snail dated at 27,000 years old. Yeah. So basically, there are some dates that are just erroneous because the assumption is, and the theory is that you have the same amount of carbon-14 in your body and your flesh and your bones as there is in the atmosphere, and that. So the experiments that we did with the jelly beans, these are assuming clean samples, untainted. And they don't normally, so if they know when somebody died, then they'll just figure, okay, well, that's, we got the date. If you're kind of talking about forensics as far as like what time of the day or night they died, that's kind of beyond my expertise, but my sense is that it's the rigor mortis and different things like that on the near term stuff.
I just wondered if they like used it against so many things that they know the actual lifespan of, but it's not.
Oh.
Their answer is not saying, oh, this person should be 35 years old. It's saying it should be 2,000 years old or whatever.
Right.
Why do you keep continuing using it on so many?
Yeah.
They tested on so many things that they do know what it's.
Had anybody watched Discovering Artie on the Discovery Channel? So on that, they actually dated the rocks because they didn't even bother to date the bones because they believed already that it was millions of years old. So they dated the rock layers above and below where they thought the skeleton was buried, and then that's how they claimed that skeleton was a certain amount. But the age, and then they also look at characteristics of the bones on the age of the actual person too.
Well, I guess my question is, do they consistently date live snails at 27,000 years old, or was it just one? It's like, so every snail they date carbon dating?
No, my sense is that it's pretty much all over the board. All over the board enough to where most engineers would not use it if that were a science that you would have to engineer from. And so that's why even scientists don't like these dates, and I'll kind of talk about the dates they do like and how they're not that good either, but it's actually better than, but radiometric dating by most people is perceived to be, hey, if the rock's a billion years old, it's a billion years old. I mean, how can you dispute that? And I think, and that's part of this course is to really just say, look, I think that if you guys leave this course with a healthy skepticism of what you hear, I'll have done my job. I think because it's really, it's not that they're always wrong and that they're always right. They're just all over the place. And so it's just not dependable. So the next dating methods that I'm going to talk about, and we're kind of, we got 30 minutes left. These are accumulation dating. And basically, they're not very scientific in my opinion, but they are, I'm going to call it just kind of allegorical. They're good things to kind of say, hey, if the Earth was such and such old, how much of this should there be in the oceans or whatever? And so I'm going to kind of go through that. So let's talk about helium. So we kind of talked about helium as being kind of a byproduct of radiation decay. So if the Earth was very old, then you would have a lot of helium that would basically be building up in the ground and in the atmosphere. So I'm going to kind of present the young Earth creationist perspective is that, look, if the helium has been building up in the atmosphere for so much time, we don't really have enough helium in our atmosphere or in the ground that would really kind of bear that out. In other words, if all this uranium has been decaying to lead for so long, where's all the helium? Well, the rate people say it's still in the zirconian crystals. But in the atmosphere, the proportion of helium, it just isn't that great. But if you look at the old Earth perspective, they would say, well, that's because helium is leaving the atmosphere almost at the same rate that it's getting picked up into the atmosphere. And so there's the kind of the two counter arguments. And you can't really measure how much helium is going out into space. So there you are. It's one of those things that's really just scientifically difficult to hang your hat on. And so some of these young Earth arguments are kind of traps too, and I'm going to try to highlight those as much as I can. John may do a better job of that. But really, the helium argument is just kind of like, well, so we just don't know. But it would be a good measurement if you could somehow measure how much helium was leaving the atmosphere. And then there's the salt in the ocean. So the salt basically enters the oceans as rivers flow into the ocean. They take salt with it. Now actually, as we've gotten more human population on the Earth, more salt is actually going into the ocean than before because, I don't know if I want to get into this, but our byproducts, after it gets treated, it creates salinity in the rivers, which then goes out into the oceans. And so, but if you measured the amount of salt that's in the oceans could only be 42 million years old if they started fresh. And you could say, well, Jeff, 42 million years, that's still a pretty long time. And, you know, if the water was fresh water to begin with, which wouldn't allow those saltwater fish and things to live in the ocean, then it'd be 42 million years old. But an old Earth perspective believes that the oceans are billions of years old. In other words, that they formed relatively early in the Earth's age. In fact, the oceans would have had to have been there for evolution to have really started. The next one is the sediment in the ocean. So as rivers flow into the ocean, they carry mud with them, and there's a believed rate that mud is carried into the oceans, and then oceans also use mud. In other words, it goes into the tectonic plates, it gets absorbed, not mud, sand or dirt, but, and they believe, they kind of know what the rates are. And so if the sediments that are there now in the ocean, and granted, sedimentary layers vary from place to place depending on where rivers are entering, but where they believe they can get some decent averages, the oceans would be about 12 million years old if they count just the sediment. Now, if you're a young Earth creationist, you believe that, well, there was a flood once upon a time, and that created a lot of different, it wasn't a uniform deposition of sediment, and so it probably could have created that level of sediment quicker than even the 12 million years that rate would have indicated. Stalactites and stalagmites. So I can't even tell you which is which. One goes up, one goes down.
Stalactites are on the ceiling.
Thank you. I'll probably forget that in the next 10 minutes. T. Okay, I got it now. But basically, there's a belief that these take quite a long time to form. In fact, we have a very popular Carlsbad Caverns, and if you go to their website, here's some excerpts that I've really just pulled off of their website. It says that a 250 million year old limestone deposit from an inland sea reef is basically where the lime has come from. 17 to 20 million years ago, the limestone rose, exposing the reef under the new layers of rock. Natural gas infused the brine, mixed with oxygen and the rainwater, and forming sulfuric acid. The acid ate through the limestone, creating the caves, and the limestone continued to rise, which evacuated acidic fluid and made room for fresh water seen today. So, and again, if you go to any geologic site in the United States or any place, you're going to read a plaque that says this stuff. I mean, it's just, it's all over. But the reality is that stalactites and stalagmites both form really quickly in certain cases. Now, they can take a long time to form. But here's a picture, and I don't know if you can really see that good. I can't even see it that good on my computer. But the upper right-hand picture is a bat that actually got stuck while a stalagmite was forming from the bottom up. And so it formed quick enough to catch him without moving. And yes, it was alive when it got stuck. And you know, there's a lot of testimonies of stalagmites and stalactites. I'm a mechanical engineer and I do a lot of work in boiler rooms, and in boilers that have hard water, they're forming right on the pipes. These things actually can form in tens of years. In fact, they can build up calcium very quickly. So it's not really necessarily old, but it's also not necessarily young either. I mean, again, a lot of these arguments, they're just kind of back and forth. Now, you can have a good argument with somebody about them, but it's very difficult to have a scientific foundation. One of the arguments that I believe is the most compelling to me personally is how many people should be on the earth? So if you're a young earth creationist, you believe that around 4004 BC, which wasn't that long ago, Adam and Eve were around. The earth was created. Now, some young earth creationists will take that back 10,000 years, and so it varies. When you kind of read literally, or at least, and you do the genealogy from Jesus all the way back to Adam, this is kind of, you know, and it's not really 4004 exactly. I mean, there's a lot of slop there, but these are the dates that you come up with. So after that, though, Adam and Eve weren't really kind of the last generation, so the world got wiped out with a flood, and there were only 8 survivors. And again, following biblical chronology, there's about 2400 to 3000 BC, somewhere in there. And again, even young earth creationists kind of debate on how long ago that was. So if you look at a pre-flood population growth of about 2.6 times the population every 150 years, and again, if you can remember in the Bible, Adam lived 900 years. So people living that long have a long time to produce offspring. In fact, if you think that if Adam lived 900 years, and if the flood was 2400 BC, he almost lived, well, within a few centuries of the flood itself, which is just, it's phenomenal to believe that that's how old somebody could be. But, so again though, you know, pre-flood really doesn't matter if you believe in a global flood. So let's estimate kind of an average growth of 2 times the population every 150 years post-flood. So Noah only lived to 600 and something. So he wasn't as old as Adam, but he still lived a heck of a long time. In fact, his descendants lived about 140 years. So they were still getting up there a lot older than we get today. So if you look at, and this is actually a logarithmic chart, so populations don't grow like lines, they grow logarithmically. So if you figure a doubling every 150 years, this is what the population growth would look like. And basically, that red line that you see at the top, that's the actual world census that we've had in our world ever since we've been taking a census. And this is a census year, so please respond. And we'll have another point on the chart. So that kind of shows that if you doubled every 150 years, you would get to the population that we basically have today. Now, I'm just going to go back. So the question could be, what is our population growing like now? Does anybody know? So it's doubling about once every 30 to 40 years. That's what our population growth is now. And that's with abortions in China. That's with abortions in the United States. So right now our population is doubling like you wouldn't believe. Now, the old Earth argument would be, well, but populations stagnate. In fact, sometimes they go down, which is true. So in the plague years, our world population went down. So it doesn't always grow. There are some things that will affect it. But all of these doublings and all of these things do include wars, and they do include normal sicknesses. So And even, you know, in the US, we don't have as many kids as at least my parents had. So, and yet we're still doubling at rates that are just beyond our imagination. So now what if the Earth was only 30,000 years old? Or at least what if humans started populating the Earth 30,000 years ago? The number is pretty much staggering, and I don't know if you can really see that well, but the yellow is billions.
Billions.
Billions of people. The red number, the red zero, is trillions. And now you go several zeros over, and that's basically what the population would be today. If humans started populating and growing at a healthy rate only 30,000 years ago. So we're going to kind of talk about this in the evolutionary series, and we're going to talk about some of the human remain finds that old Earth evolutionists believe are 1.8 million years old. So if they're 1.8 million years old, in other words, if we had all those people back at 1.8 million years, this number is just beyond belief. And humans have to grow at a certain rate, or you just become extinct. And people do become, or not people, but races of people have become extinct. Animals species have become extinct. So extinction happens too.
That rationale from old earthers, that's not old earth creationists, that's old earth evolutionists.
Right.
Okay.
Right. Yeah, I mean, I think that when you look at old Earth creationists, there's a creation event that happened in the age of the Earth. Right.
They still have the flood, so they'd still have the
Yep.
starting over point.
Yep, exactly. And that, now the flood part depends on, because some old Earth creationists believe it was a global flood, some believe it was a local flood. So then it depends on that perspective. So those are kind of some, I would say all of these accumulation methods are not, in fact, I would say, when we kind of call this class creation science, but science is something that's testable, it's provable. And all of my arguments that I'm making for a young Earth or for creation, not testable by science. But neither are any of the other things that are kind of given as scientific data today. So let's just kind of talk about a few more, and then we'll wrap up. So ice core samples and tree rings. These are things that you'd think you could get a handle on. So right here in Golden, we have ice that's very long. And they're ice core samples. In fact, these were used to kind of determine CO2 concentrations in the atmosphere when we looked at CO2, global warming studies, and different things like that. So when this ice core that I'm showing kind of a very small picture of was taken, it was thought to be 135,000 years old. So they cored down 10,000 feet and believed that they had 135,000 years worth of data. One of the arguments against that, and you would think that, so if you see one ring, you know, you've got a year, because it was a seasonal cycle, and you basically count up the number of rings. Well, in 1942, a P-38 squadron flew B-17s. They were running low on fuel, and they needed to ditch their planes. And they didn't like wreck them, they kind of landed them on an ice field. They got out okay, but their planes, they pretty much had to leave there. And two gentlemen in 1990 wanted to recover the planes. They had historic significance, they were worth quite a bit of money, and so their names were Epps and Taylor. They wanted to melt a shaft down to the planes to pull up the planes. Well, they went down about 263 feet before they got to the plane. And it actually took them a lot longer than they thought, because the planes were a lot deeper than they imagined that they would be, because, again, they didn't feel like snow cover over just 50 years or so would be that deep, or ice cover. And what it turned out was it's 263 feet. So if you kind of take the 263 feet and you look at that in the realm of the 10,000 feet, so if you got 40 years, or 48 years rather, for 263 feet, then the 10,000 feet would take about 2,000 years. So the ice core that was purported to be 135,000 years old could have only been 2,000 years old. So, tree rings. This is something that I think everybody can kind of get a handle on. One of the oldest trees that's found is called Methuselah, and it's actually in California, high up on a mountaintop, and it's got 4,768 rings. Now, rings in trees, you can get 2 rings in a year. You can get no rings in a year, depending on what the season was and a few other different things. But that's basically the oldest tree that they found alive. Now, there is one that's older, and I actually found this on the internet. And when I looked at it, I'm thinking, so that's a pretty scrawny tree. How could it be older than Methuselah? Methuselah at least looks old. It's this old, gnarly, hard-looking tree, kind of thick. And what I found out was that tree that you see in the picture really isn't. So they think that this tree is 9,000 years old. Actually 9,550 years old, to be exact. And when I looked at this, I thought, well, wow, that's, again, it's a skinny tree. Well, the tree only has 50 rings on it. So to me, in my simple mind, that's a 50-year-old tree. But what they found is remnants of the root system and the pine cones around the tree that they've carbon dated to 9,000 years. So remnants of the tree date older. They believe it's part of the same root system of that very old tree. So I think this one's kind of a reach. But see, because I can see the tree rings, that's kind of more obvious to me. But the carbon dating is, again, kind of going back to a science that I just feel like isn't really very reliable.
How did they find the range and cut the tree? How do they get their rings on them?
They take a core, and they do a core right through the middle of the tree, and then they count the rings on the core.
I'm assuming the area they found the tree in wasn't very densely populated, right? I mean, people live longer than 50 years, right? Couldn't someone be like, yeah, that tree wasn't there, right? Or at least that it was smaller, or?
Yeah, no, and in fact, well, the scientists would say that sprig of the tree is 50 years old. So they're okay there. What they're saying, though, is that sprig is part of a tree root system that is ancient. Now, the roots don't test that old either. And again, I mean, you think about carbon dating, you don't date things carbon dating until it dies. So it's the wood chips, it's something else that's dead, that's near that little tree, that's being dated to be older, to be very much older.
Well, another baseline you think would make sense is if you just started testing that area, like all the pine cones and all the trees in that area, and if they all started or were younger, or at least that age or younger, then you could be like, okay, for this area, that's a good baseline. But if you started so based on what we're saying, they should be all over the place. Like they tested another pine cone and it was 400 years old.
Yeah.
They tested another one and it was 4 million years old.
Right.
They just kept fluctuating. And to me, that would be another sign that at least get a baseline for that area.
Yeah. Now, on the tree ring study, one of the things that an old Earth perspective would actually show is that there are some tree rings that they've cut from 2 different samples of tree. And these are typically, when I say cut, some of them are petrified. But they believe that they can match up some of the rings with some of the petrified wood to some of the new wood, and they come up with longer times that way, but not on a single actual tree. So, and I mean, I think that there's a good passage of biblical passage that we probably all should kind of take heed to, and God just tells Job, where were you when I created, this? And I think that's, even when I kind of highlight some of these arguments, I mean, I wasn't there. These are just kind of things that I think that you need to understand that really contradict a lot of what you probably get told. So, all right.
Hey, I can relate to that.